Welcome back to my Budget App series. If you're new, this is only one video in a large series of more than 10 videos where I built an entire application from scratch. The app is for personal finance and budgeting, tracking expenses. In this video, I will talk about automated testing. Now, testing is a vast and extremely interesting topic. In fact, it's a career path for many people that work professionally as QAs, as automated testing professionals that build testing suites. Let's just outline from first principles the goals of automated tests. Automated tests are nothing more than a suite of software, a separate program, you can look at it, that tests another piece of software with automated rules, which you outline algorithmically, which are expected to be true. Ideally, these tests should help you when you're building a larger piece of software with many other people and to make small changes to catch errors or breaks in other aspects of your application that are affected by your changes without testing the entire app after every single change and before deploying to production, which is sometimes just not possible. You cannot always test every use case manually. So automated testing is the way to actually ensure software reliability in a dynamic environment where you do continuous development on a piece of software that changes regularly. We have unit tests that are very small pieces of tests that test a single unit. That is usually in the context of JavaScript, TypeScript software. You think of a function, that's a good single unit, a function call. A function, a method, that's usually a unit that you're testing. And unit tests are extremely specific. They are the smallest and most specific kind of tests that are meant to test every single unit in your application with good coverage. And the point here is to test as many units as possible, and especially the units that are critical, that contain a lot of business logic, so that you're sure the end result of those units, those functions, is consistent and its output is correct. And if you change another unit in the application that this unit depends on, the specific unit that is tested does not break, or its main functionality at least. So talking about integration between units, functions, if you think of functions, methods as units, they usually interact with other methods. That's how an application works. Units in isolation don't do anything really. So the next level of tests is integration, which are supposed to test the integration of units with one another and the integration of larger pieces as well. So generally, a simplified view is that unit tests are the smallest fraction tests for the most specific single units of code, and integration tests are just one level higher, one level more general. They test the integration of these units and if it works as expected. Another family of tests is end-to-end testing, or E2E. This is testing the application. To explain it in layman terms, testing the application as if you're a user, but with automation. So if you think about, let's put this into context. If you think about, for example, a web app, that's a to-do list. Unit tests would be testing single functions, which are, for example, to parse the to-do text, to complete the to-do. If that function does the correct side effect, if that function returns the correct item. Integration tests would test if the single units in that case integrate correctly, meaning does for example, does one function of those that are to complete the to-dos call another? Do they integrate correctly, given that we've already tested with unit tests that their output in isolation is correct? Do they integrate correctly one with the other so that the output is as presumed? If you click complete a to-do, a couple of functions should be called one after the other, chained or in whatever stack. Integration tests can test that and any other kind of integration, really. They're not that limited in terms of scope, just my example is limiting. And end-to-end testing wouldn't really care about the code. End-to-end testing would start some kind of a browser, some kind of an environment where it can interact like a user, but with tools that allow allow us to navigate that browser with software, meaning it would click a button if we stick with the to-do example. End-to-end testing would be open the to-do app, create a new to-do using the same controls the user does. Click a button, enter text in the input, click add, expect the actual to-do item to be added, then remove it. So just automate. Really, end-to-end testing should be streamlined, manual testing, the same workflow, but automated. So the thing about these tests is that there are suites of libraries that allow you to write these with code relatively easily. With close to natural language, they have very nice APIs, but they take time and they take development effort. Usually, software would aim to have at least some coverage. Coverage meaning how much of the software is covered with automated tests in terms of percentage. What percentage of the lines of code are covered with tests? This is largely meaningless, especially for end-to-end testing, because you're not concerned with coverage there. You're interacting like a user. In terms of unit integration tests, it isn't meaningless. It is meaningful to test lines and more lines of code, but that's not everything. You can basically write bad unit tests for 100% coverage of your code base, and you can introduce bugs, and the tests won't catch them. The tests need to be good and meaningful, and you need to use just think about the tests and what is the best and most efficient way to test a function programmatically, algorithmically, so that in the future it would help you identify an error when you make it. I want to say that because a lot of people look at tests like a raw exercise of writing meaningless code so that you just tick a checkbox or increase the percentage of coverage and then say, okay, I'm done. We have 100% coverage. Everything is superb in terms of quality. Well, not really. Now, another challenge is this is an MVP, so I'm writing a piece of software myself and I want it to be as reliable as possible, but I don't have unlimited resources in terms of time, just sheer time to do it. So covering everything with unit integration, end-to-end tests, and having the most robust testing suite is really not an option because simply if limited resources, at least for now, I need to optimize my time. And I think this is the case with many people. I just want to focus my time, my limited time, on the most important automated testing that will help me identify the most amount of errors, at least now for the MVP. Of course, the testing suite will later be expanded to have more coverage, basically. Ideally, at one point in the future, everything will be covered with a lot of tests and the software should be much more robust when making changes. Now, that being said, I need a strategy. We have the backend service, which is in Node.js REST API with Fastify and TypeORM and PostgreSQL. We have the web client, which is a Next.js application, and we have the user interface, BWUI. Let's call it UA library of components. And these are different in terms of how you can approach them. You can use all of these types of tests for all of these packages. The problem is what is most efficient for each one of those. First of all, end-to-end testing is awesome. So if you don't have any automated tests on your software right now, in my opinion, starting with end-to-end testing is great because a single end-to-end test can cover and uncover a lot of problems. And it just is the most efficient in terms of time to return ratio because clicking, for example, interacting like a user and logging in triggers the web client, the backend service, the server, the controllers, the models, the database, everything. And it checks if the UI components are rendered correctly. So as the name suggests, it tests end to end. So with a single line of code, you test a lot of things and if they're working correctly. Now, this isn't perfect, of course. It will not help you identify the exact problem. Yes, you will need to investigate a lot with end-to-end testing, but you have the highest chance to get a testing error, automated testing error, if you have a mistake with end-to-end testing. So end-to-end testing is valuable in terms of its return on investment being development time. So that is absolutely where I am going to start. In fact, I did start. And the end-to-end testing setup is actually in the mono repo right now, as it doesn't belong to any one of these packages, in my opinion. I am testing the first suite I'm starting with is testing the application from the web client end to end. So it interacts with it like a user. And there's a basic testing suite. I'm using Playwright. This is the website. It's built by Microsoft. It's open source. An alternative to Playwright is Cypress or just using Selenium. Playwright, what it does, if you're not familiar, is it launches a browser and it executes a set of instructions you give it. For example, you request the browser to go to a page, then check if a text or element is available on the page. You can get items and click on them. You can type in input fields. You can expect differences. And this way you test like a user with a simple API. So this is what I have done so far. Here I have my Playwright configuration. All my tests are in this end-to-end directory. And here I'm going to go through my most basic testing suite. Keep in mind, this is just the bare minimum. I'm just starting here. So first of all, we have visual tests. Visual tests are very useful in checking the user interface elements, and if at least the user interface is rendered without errors, because many errors, a lot of errors can be caught simply by checking if a page is rendered correctly. Like a lot of errors will break you up to the point where nothing will render. A lot of exceptions. So we have visual gated and non-gated. Gated meaning the pages or the views that are gated for authenticated users only. And the non-gated are simpler. As you can see, this is extremely simple. We just define a single test item, which in this case is the login page in this case, but you can write anything here, of course. And then I go to, in this case, the base URL. I have a config here. We just going to the base URL, which is localhost. So the test machine, I'll talk about continuous integration delivery in another video because that is another large topic. The test machine will run the app in a Docker container and then start Playwright so that we have a complete environment to test really end to end. And here we go to the base URL as that is the login page. And I have a wait for timeout. This will just wait 100 milliseconds. This is a good practice when doing visual tests, just to make sure that everything is set out. Now, my views are well built. They don't have any cumulative layout shift after they load, but it's a good practice to just wait 100 milliseconds or a couple of milliseconds. 100 is a lot. Just to make sure that everything is set out, everything is loaded correctly, and then take a screenshot of the page. And that takes a screenshot of the page that is saved right here. And you commit that in your testing suite because that state is saved. And as you can see, it saved it with the platform Darwin. In this case, it was run on Mac OS once. And here's what it saved. The entire application. In this case, we're talking about visual non-gated login. So visual non-gated login Chromium Firefox WebKit. If I open login, it saved as you. And when I run the testing suite, it will compare the current screenshot it took with the reference. And that will catch errors. For example, if the login page doesn't render at all, if I don't get this input, which can happen if I have an error, a server-side error, something that breaks the client completely, I'll get an automated testing failure and I'll be able to debug. If some of my UI components breaks on this page, we have a button, an input field, labels. If any of those break or are different, my tests will fail and I'll be able to identify that. So this is one level of testing, the most basic level of testing. If you have no testing, as I said, end-to-end visual tests are a great place to start. They can ensure some quality. Now, visual gated is more interesting. You need to log in. Now, each one of these opens a new session, a new browser window entirely without cache. So you need to use a storage state saving file, and that's done easily with Playwright. I have this authenticate setup, and what it does is it goes to the login page. As you can see, like a user, it logs in. It gets the uh, email field, fills in the test user, gets the password field, fills in the test password, then gets the login button and clicks it like a user. And then we save the state of the page, which we'll just save the cookies. That's what you can imagine. The cookies, the storage, the local storage or whatever. And that's basically what you will be able, just the entire browser state so that you can use the session. Keep in mind, here we have authentication details. It's not good to have those. They should be really environment variables, even though in this case, these are the test user details, which are seeded and they're used only for this case. Just one user that's used only for testing. Still, that opens you to some vulnerabilities because knowing that this password exists and is in the database, you can try to decode the encoded hashes or whatever of other users. So use an environment variable when you commit that to your repository. I'm still working on it, so that's the reason why it's in this state currently. Now, this is how the authenticate setup works, and using this, I can test the gated pages, which is absolutely the same process. Wait for timeout, screenshot. That's all you need to do. And this line, expect page to have screenshot, is really everything that Playwright requires to make a visual test. The first time you run it will always fail and make these screenshots. The second time will compare. That's how it works. It's wonderful and very simple. And the return on investment, so to speak, development investment is very large. Now, these are the bare minimum tests, visual tests. I have other layers as well in end-to-end testing. As you can see here, I have the login spec. And here, I test more specific things. For example, this is for the login page. We navigate to it and we check if login page has the necessary form fields. Now, admittedly, this overlaps a bit with the visual tests. And you can argue it might not be that important because if any form field is missing, the visual test will fail. Still, this is very minimal, and I think this redundancy is good in case one test fails for some reason or doesn't fail. In this case, not failing is a failure for a test. Yeah, this checks just if the basic elements are available. And it checks if error handling is in place. For example, if invalid details are added. If the login page redirects correctly when you log in, which actually is a big deal. Think about it. This is the entire point of this page, and this test really will test it end to end because so far we've tested it visually. We know all the fields are there. They look as you expect them to. If you enter invalid details, you get a correct invalid message, and if you enter the correct details and click the correct buttons or submit the correct events, you get redirected to the appropriate page. This really tested the login workflow, the login user journey entirely. This covers a lot of code automatically, and that's really what I mean by end-to-end tests are extremely valuable in terms of return. And all of this is only a couple of lines of code, to be honest. So I'm extremely happy about that. And I have similar tests for the other views. Here I test settings and if the main user interface elements are there and visible, which is a little bit redundant with the visual tests, but still, it can help. Now, this tests the sign-up process. This tests if I can create a user successfully by creating a user and then attempting to log in with it. It tests if the new user has the new user experience, meaning the appropriate items created in your first budget to help you get started, which is a big deal. And we also have other very lean tests for transactions and reporting, which primarily at this point test user interface if all the UI elements are in place and correctly positioned. Now, at this point, I need to expand my end-to-end test more. I have good testing coverage of the login and sign up views, where I test end-to-end the functionality, meaning I click, I enter the details, I check sign in, sign up, and if it works correctly, and if errors are handled correctly. I need to also do the same amount of testing of the functionality for these views, as I currently only test if the main user interface elements are visible with visual and end-to-end testing. I need to go a little bit in depth, for example, here in the budget, in creating a new transaction and checking if it exists here. In searching for that transaction, then adding new categories, changing the amounts, and checking if everything is as expected for a user. I will add unit and integration tests, but that needs to happen for the specific packages, meaning the backend service, the web client, and the UI library. The UI library is the least important, at least in my opinion, because end-to-end testing really covers a lot of the UI library, at least visually. It tests if the components are consistently rendering between versions. So if I accidentally change visually a button or an input, I can catch that with visual tests. Now, that's not entirely true because the UI library also has, for example, the data grid, which has some functionality for sorting, filtering. So a little bit of unit tests here. Let me copy. I want to do that. A little bit of unit tests here will be useful for these specific complex components and their most critical logic. It's useless to unit test everything here that is included because it's not, I wouldn't call it useless, it's just not valuable. It wouldn't bring any value writing and spending the time because the end-to-end testing can catch most of the errors I'll be able to identify with unit tests here just as well at this stage. Now, the web client and the backend service are a different thing. In both of these, we have business logic. Most of the business logic is in backend service, but inevitably, some business logic is in the web client. In modern software development, you need to have business logic in the web client in order to ensure good user experience sometimes, so that the user doesn't wait for server response for every single small action. You implement some things on the client so that they are faster, fluid. You want a certain UX. So, both of these need to get unit tests. Now, I added unit tests to the UI library, but they probably won't happen at this stage of the MVP. Here, I will have unit and integration tests. And the same thing will happen with the backend service. And I would start with that because most of the business logic is here. If I don't catch something with end-to-end testing, if I have a good unit and integration testing suite here, I'll be able to identify most of my serious issues. Because after all, the web or any client just interact with this API for the most important actions, which are data manipulation. Now, here's the interesting part. These tests, how am I going to implement that? I haven't done that yet. What I have started with currently is to implement end-to-end testing, at least a very start with the end-to-end testing and what I've shown you. Visual tests and the basic end-to-end tests for login and sign up. And I am going to work on improving the end-to-end testing coverage for the other views. But I want to take the time to set up and strategize how I'm going to test my backend service. And the web client will be very similar to that. It's not that different because the web client is mostly React components. And I'm not going to really test them thoroughly. That can be covered with visual testing, most of that, and end-to-end testing. What I want to test on the web client are specific business logic related functions, like the functions that transform data before they pass it to the Sankey chart, the functions that transform data before they render this chart, the functions that how the data is received, transformed, and processed to render in these grids, etc. Now, how am I going to test the backend service? I will use Jest. Really, the testing framework is not that important. Jest is fine, I guess. It's most popular currently. You have Mocha as an alternative, for example, or Vitest if you're using something like Vite. But you can use Vitest standalone as well. The API of these is similar. It's very simple. And really the essence of them is the same. I've had great experience with Jest. It's easy to set up, quick enough, at least for a testing framework. Performance is good enough. And I've never had any issue with setup. It's extremely easy to set up. You don't need to do almost anything to start. And let's set it up so that we see how it goes. I'm just going to getting started. We need to install it as a dependency. As I mentioned, I'll start with my backend service. So I'll go to packages. Let's see what we have here. With our backend service, I'll open the folder. And the first step, as it says, is to install the, let me just type that. Install Jest. Okay, Jest installed. And we have it in our package JSON. Here it is. And the next step, let's see, the getting started guide is to, I think, add it in the scripts by the name test and just run Jest. Now we need to make a testing file. The folder structure for unit and integration testing I would recommend is to have a test folder next to your source folder and mirror the source folder structure. So let's start with this helper, for example. Validation messages, a very simple function that I want to test. It's in source helpers validation messages. I will create a helpers function folder in test, and I will create validation messages.spec.ts. And this is how testing files are called. You would usually have either JS or TypeScript depending on what you're using, and .spec or .test. What this file will do is it will import that function and then test it using a statement like this one. Test, like here's the sample test. Let me zoom. For this sum function, it imports it and then just uses the test. Jest has global functions, so you don't need to import them every time. Describe what you're testing, 1 plus 2 to equal 3 using the sum function, and it expects, this is an assertion. In this case, I'll simplify it, expect 3 to be 3. This will always be passing, but I want to test if my testing framework is working. And I have an IntelliSense error, cannot find name test. That's because we don't have the types. Try npm install types Jest. Very useful IntelliSense, a very useful recommendation from Visual Studio Code in this case. So let's install that. There we go. And this should disappear, and it does. Now, I don't expect it to run if I run test, but it does. Let me just run it again so that we can see the output. Currently, we have just this synthetic test because it doesn't really do much. It just tests if 3 equals 3, which is always true. But this is how an automated testing unit test basically looks. It passes, it's green, so all of the assertions are correct and it doesn't throw. And it adds, it lists the test and how much time it took to run. If there is an error, it will fail. And this will run when you deploy your app. That's the idea. All of these tests run when you deploy your app. And if you make a mistake and something breaks, you get this error and you go investigate the bug. You fix it so that the test starts to pass. And hopefully you find an error you made and fix it before it ships to your users. We wanted to test this function. How would that work? You can import it. In this case, it's an exported function already. Get is invalid message. Just like you would use it in the rest of your app, this test is the same user to your API, and it can just validate if it's correct. Now you have, with automated testing, we have the so-called arrange, act, and assert pattern, which is really the AAA pattern, just some general idea as to how to write tests, which is self-explanatory and you can figure it out by yourself if you know how you're writing tests, but I want to mention it if you're a complete beginner. Arrange means just arranging the test actors, so to speak, or the items you're going to test, which is just some inputs maybe. In this case, this function just formats a label and tells us the label is invalid. It's not even meaningful to test this with unit tests. If you don't have a unit test, testing this function will not improve software quality dramatically, believe me. What improves software quality dramatically is testing functions that have business logic that can really break an application seriously. This is a joke, really, but it's a good one to start with to demonstrate this and test the setup. So what would we do? Let's just add a test label. It can be anything. Let's do something more real. For example, first name. And the expected string. Let's say that this is the expected string. And now we act, meaning we execute the unit. In this case, a function. I'll save it in a result variable and I'll pass label. And lastly, we assert, we check if it's true. And in this case, we expect result to be expected string. And this really tests the function complete. Let's run. And we have an error. Let's see what it is. We have test should fail to run. Yeah, we have an error with the import. Yeah, the TypeScript configuration. So we need to install Jest as a dev dependency to handle the imports, basically. And now, if we run again, we still have a failure. Why is that? We need to generate the config npm npx jest. Let's see, config init. And it creates a configuration file which contains some stuff that is really not that interesting. Not start, excuse me, test. Let's run it again. And my test runs. Now this should be returns the correctly formatted error message. Let's run again. Now we have a valid test. Now if I change something here, more specifically, if I break something here accidentally and rerun the test, it will fail. Just so that I show you how it fails. There we go. It's very specific. Returns the correctly formatted error message. Expected is this. This is what we received. And that's great for debugging. The good thing about unit tests is when they fail, you see very specifically where they failed. Up to a single unit. End-to-end testing can fail easily if you break something. And they test a lot of things with a little bit of code, but then you need to investigate a lot. Because you see what the user sees as an error. Sometimes it's hard to identify where the bug comes from and it takes a lot of time. So that's a very big pro of unit testing. You get a very specific clue where you went wrong and where to search for a fix. Okay, so this is my basically framework for unit testing. Now you might ask, this is an helper synchronous function. And it's simple to test that. Yeah, it's pure function, completely isolated. No, this is an API with controllers, budget controller, users controller, and endpoints, RESTful endpoints that basically create data in a database. So testing that is a little bit more complex, but I do have a plan for that. Here's how this works. We have this application is quite simple in its essence. We have Fastify, which is a REST client, a RESTful API server, Node.js server, and TypeORM, an ORM that deals with data manipulation. It creates objects in a database. To test this, ideally, we need to test controllers and models. This is what this application really has, models and controllers. The helpers are really not interesting. There are functions like this one, seeding. It's not interesting at all. So we need to test the models and the controllers. The models contain most of the business logic together, of course, with the controllers. So how are we going to do that? We need, ideally, to have an access to a database. And you have a couple of options. When you use an ORM, one advantage of an ORM is that here you just create a new data source and the interface stays the same. So in this case, the type of connection is Postgres, but TypeORM can work with many SQL-based relational databases. So in theory, you could put SQLite here and use an in-memory or single file database to run unit tests. Just run the app, meaning initiate this application instance and start it like the app would, and then execute controllers, models, and their functions and check the database if the records have been modified correctly. This is one option. Another option is that, unfortunately, I cannot use an SQLite database because I use some complex data types which are only supported by Postgres and MySQL, but both can't run really in memory or something like that. So, for example, my which model was it? Category, I think. Yes. Category type, this column in the database is an enum type, and SQLite doesn't support enum types. So we are limited to that. But that's not really a problem. What I'm going to do is start a Postgres database, and these tests will run on deployment. And I will have a special database for testing, one instance, one database for testing purposes only that will run all the time. And unit tests will use it to just run the testing on the deployment machine. And my plant, let me go to Excalibur real quick. My plan for continuous integration right now is when you deploy locally, you deploy to GitHub. There, what happens is you deploy, you run, first you build the application, of course, because that needs to happen. Then you run tests. This is happening on a single server. Then you run tests. Server meaning a Linux machine, basically. You run these automated tests. One happens after the other, of course. Then if the tests pass, if the tests don't pass, you stop here. If the tests pass, you deploy a staging environment. And then on request, you deploy to production. So this is so that you can manually test after the automated tests run on a staging environment. Make sure that everything is correct manually, because you always should do that, and then deploy. That's the plan. And these tests can absolutely connect to a database, because they will be running on this machine, which will have the production database maybe, or at least the staging database, or they can run on a separate testing server that's just for testing, and it can have a database specifically for testing. That's completely fine and worth it. So I will just create a new data source with TypeORM. That's my plan right now. And in fact, I will create that right now. ATS file, which will have a similar setup. Let me have a similar setup, and it can use configure environment variables here. But for now, I will input some normal values. Let me see if I have Postgres running here in my Docker. Yeah, I made a container for that, BW testdb, and I have it running on 5432, 5432. Is that correct? I always forget the Postgres port. 5432, yes. With a certain username. How was it? Postgres is the default user. Now, this of course will be all environment variables. And you need to have a simple test database. And I remove these entities. I need to import them, of course. Import them again right here. And I need to update the imports like this. Okay. And this will be my test data source. just for testing. And my tests can utilize that, at least my tests which require data access, which will be most of them really. And now I can start writing my tests for my models. For example, if I have user, how do I call it? User spec DS. So this will potentially test my user model at some point. And what that would do is we of course need to start the database first. And that can happen with a before all function. Let me see. Yeah, we have this function in Jest. And here the example is with a global database. And this function that runs before all tests. And you can insert it in a spec. What I would probably do is make a small function helper that returns the database so that I can use it. But this runs before. Oh, and I need to import this test data source right here, like so. I need to fix that quotes preference. But so before all, just let me see. What does the application do really? I actually need to start the entire app potentially if I want to really test end to end. Not end to end, but if I want to unit test the application, I probably should start server. And to do that, I might need to modify the app a bit. Now, this you usually don't need to modify your application a lot when unit testing, and that's not the point of it. It's not the point to break the app uh, while writing tests for it. But very frequently, for example, you would need to export something if you want to test it, which doesn't really have a lot of side effects. But naturally, you might need to export a unit to test it if it's only used internally. That's sometimes what happens. And in this case, we also need to be able to pass data source as an option, because let's check what this application does. It has a server, which is a Fastify instance, and we don't need to modify that. This creates a new Fastify instance. We don't care about that. It starts an HTTP server. That's fine. It just Fastify. Registers Fastify plugins, controllers, and the main function initializes this data source. But this data source is just imported specifically from app data source. So ideally, this application class should work with a different data source. And we can pass it here in the constructor. And when we do that, let me check what is the type of that data source. Okay. Here we need to define it. And instead of using app data source import, we can use this data source initialize. And when we create a new app instance, we pass the main data source. And what we can do now, after we export application as well, is we can import application. And before starting the app, before starting the testing suite, we can theoretically create a new app instance with the test data source and run its main function. Everything in Jest tests can be asynchronous. I mean, that's completely fine. Main would not stop, so you shouldn't wait for it, really. Yeah. So this is what is currently happening. Now, this is one approach to start the app. This way you can test controllers, really, because I'm currently in the model spec, but if you're testing controllers, you can, the test can just be to do a RESTful API call as a client and then test, check the database. That is a good approach. You sometimes don't need to go to the level of testing models, really, because really this is a layered architecture. Let me show you something. This is a layered architecture, and if we're talking about value, a server has controllers and models, at least an HTTP, RESTful API server. That's most of them. And you get an HTTP request that's incoming. That request is to a controller. The controller is the endpoint. And the controller is, for example, post users to create a new user. The controller exclusively and only the controller interacts with models. So if you do write tests for controllers and check if they are controllers as units behave correctly, you have very good coverage of the models as well. So I probably will start with controllers testing and make sure all of my controllers are covered and only write specific unit tests for the models if necessary. The good thing about the models is they can be tested independently without starting in the server. How? Because they are, here they are. They're just classes that interact with a database. And the thing about testing models is in some cases, it's great, especially if you're writing SQL queries. But here, many of my models are empty and they don't have business logic because their business logic is just CRUD operations, create, read, update, delete, which is implemented by TypeORM. And I can sort of rely that the functionality is working because TypeORM have their own testing suits and, a community that develops it. And this model, for example, it doesn't contain any business logic. There's nothing. I have just a class that has fields. And what I execute is create, update, delete, and read. But if some of the models, for example, this one has business logic, as you can see. Here I have fields and a function, generate current amount. It should be covered with tests because it's important. This is business logic, important business logic, and it should be tested. But as far as I can see, I think this is the only. Okay, and of course the caching mechanism of user that can be tested as well, although that will be kind of hard to test. Not that hard really. You can test it with is password valid and hash password. Just check that and the caching as well. Of course, you can check the validation of the models. That is one area which you can test because it is some logic. Business logic is validation is important, and that is one thing we could test. We can test, but as I mentioned, the controllers are more valuable because they will test the most amount of business logic in that backend service. And this is my approach. Now, I'm not going to write these tests live in a video because it will take a lot of time. Even that, explaining my strategy and how I plan to approach it did take quite a long time, considering I had already written end-to-end tests to some extent. So it's not really feasible to write these tests live. To summarize, I have end-to-end tests right here, visual and end-to-end tests, which I will expand further. That let me go here. That test my entire app so far, which currently includes a web client. In the future, it might include a mobile client as well. It will, in fact, that's a spoiler. And it tests everything. So that is what I rely on mostly to ensure reliability, at least in these early MVP stages. And then I will focus on unit and integration tests primarily for the backend service. Here I'll attempt to have close to 100% coverage of the most important business logic and services. And I will write a unit and integration test for the web client, focusing only, not trying to get 100% coverage at this point, only focusing on important components and business logic functions that I have on the client as an exception for better UX. I will not write unit and integration tests for UI library at this point because the end-to-end testing can catch a lot of errors related to that. At a later stage, I would add some unit tests, especially for complex components like my data grid. And this is my testing plan. All of this, as I mentioned, will be deployed in a CI/CD pipeline like this. this is production. In fact, I have done some of this setup already, but I will document it in a video a little bit later. So the next video you can expect will be, I hope by this stage I will have advanced more with my testing and probably even written all the unit and integration tests and the end-to-end tests I require for now. And I will focus and show you how I do this CI/CD pipeline in GitHub Actions with a Linux server or multiple servers. We'll see how it goes. But this is my plan. You can expect a video for continuous integration and continuous delivery, where I can also show you a little bit more of the tests because they are a part of CI/CD. This stage especially is maybe the most important part of continuous integration and to ensure the quality of what you're shipping. Thank you for watching and take care.